welcome and good afternoon. Thank you all for joining our Winncom Technologies Tech Talk, Private LTE 5G, Unlocking Connectivity for Enterprises and Service Providers. Here to present from Winncom, our Solutions Architect, Michael Hughes. If anyone has any questions throughout the presentation, please feel free to add them into the chat and they will be addressed at the end of the Tech Talk. Michael, you're up.
Thank you, Dawn. Thank you, everybody, for joining today's Tech Talk. I'm with Winncom Technologies. We're a global value-added wireless, everything wireless distributor, also focusing on fiber optic, GPON type networks. And we're supported by, and I'm in a group of awesome, great professional engineers across the globe that I love working with. So that's our value add, is that we have professional engineering services. So today I'm going to do a tech talk on private LTE and 5G. I'm going to turn my camera off here to save some bandwidth. So entitled Unlocking Connectivity for Enterprises and Service Providers. My name is Michael Hughes. I'm, again, like Dawn said, I'm a solutions architect at Winncom. My email address is there. That is not me on that tower, but I thought it would be awesome if it was me on the tower. So today, I'll go over what private LTE is, kind of compare it to 5G. I'll go over the relationships or the features and benefits of private LTE. I'll compare it to fixed wireless point to multi-point. I'll compare it to Wi-Fi and tell you how it's different. I'll go over a few use cases and actual use cases, and then I'll go over the architecture and then some deployment best practices or just the deployment of private LTE. So what is private LTE? This first sentence, every word's pretty important. So it's a private wireless cellular data network. So it's private, meaning that it's different from the public tier 1 MNO cellular, T-Mobile, Verizon, AT&T service providers. It's private, meaning you build it to be your own private network. Cellular helps to give it the meaning that it's based on the cellular technology that follows the 3GPP standards and protocols. So it's built on standards, and then it's a data network. It's not necessarily a voice network. I'll talk about that in a little bit, but it's a data network. It is independent from the public tier 1 service providers like T-Mobile, AT&T, and Verizon, and the rest of them. It's independent from them. You build your own private network. However, there are things that you can do to perhaps roam out from your private LTE network onto a tier 1 network and still maintain that connectivity back to your private LTE network. So it's independent from it, totally separate from it, but you can do some pretty neat things where you can roam out to a public network, but still actually remain on your private network, even though you're in the public network. You can build it out to be indoor, outdoor. It has mobility, so you can have devices that move around just like your cell phone, but it's also can be deployed in a fixed wireless environment. And again, like I said, it's a data network. LTE is a data network. 5G is a data network. I have a lot of people who talk about deploying or wanting to deploy private LTE networks, and they think that it might be capable of like I can build out a private LTE network, put my cell phone on it, and connect to T-Mobile and make voice phone calls. That's not necessarily the case. LTE is a data network. You can enable it to do voice, and it's a little bit more difficult to do. So when you build out a private LTE network, you're really building out a data network. If you want it to support voice, you can. It's a little bit more complex, but there's a component in the core, and I won't get into this right now, and maybe it's another tech talk, but there's a component in the cellular core that you would need. It's called an IMS. It's a IP multimedia system that actually turns it turns that data network into a voice over LTE network, or similar to a voice over IP network over Wi-Fi. So in your private LTE network, you'd actually be doing voice over LTE, which acts just like voice over IP. My T-Mobile phone uses voice over LTE. The IMS system in the core acts as like a SIP gateway. And then if you actually wanted to, you can have and then from that SIP gateway, you could interconnect it to an IP-based PBX that's on your private branch. You can assign extensions to it and make native dialing phone calls from your cell phones. Or you could integrate it into a voice over IP or SIP public service like Alianza, or somebody that would provide you with public telephone numbers that would come out on your extensions from your PBX, and then you could dial out into the public network. So there are ways to make it a voice-enabled network. It takes a little extra effort to do that. The other thing that people are using private LTE networks for, in order to support voice or to bring in those public carriers, there's a thing that you probably heard about, neutral host, but there's a new technology called MOCN, which is Mobile Operator Core Network, which allows, and then maybe this is another tech talk too, it allows for you to build out a private radio network, and then if you have the relationships and the interaction between the public carriers, they would actually use your radios for their customers to attach to. So if you had a building that didn't have any T-Mobile or AT&T voice service in it just because they didn't have coverage there, they might engage in this MOCN arrangement with you, use their radios. It's not actually a roaming or inbound or outbound roaming arrangement. It's more of it's a technology where it uses your radios, but then from the radios, their customers go straight out to their, like a T-Mobile core network, versus going through your private core. So it uses your radios. It's a complicated thing to do. It's the technology is there. I've worked for companies where we've actually deployed it, so it's deployable and it works. There's service providers like my friends at Infinigy that actually provide it as a service, but it's complex to do, and it needs the participation from the tier 1 carriers, which may be a difficult thing to do. And then the third way is that you can, for voice, is you can use it you can use private LTE as a digital DAS, and actually, if you have the relationship with tier 1s, you can they can bring their basebands into your private network and then broadcast out broadcast out through their frequencies in your private network to support their customers, not necessarily your private network customers. And I'll talk a little bit more about that too. But it's just a different way of doing it. So that's voice. That's probably what I'm going to talk about on voice. The other thing too that's kind of neat is, and I said it's independent from the public networks, but you can, again, if you have the relationships with the public carriers, you can get like an outbound roaming agreement from another carrier, or from, like, say, AT&T, and you can outbound roam from your private LTE network onto AT&T's network if you go off net from your private network. And when you do that, you can actually, you're not on AT&T's network. You're still on your private network, although you're roaming to AT&T. When you're roaming, they send all the data back to your core. So you're really still on your private network, even though you're on AT&T's network. So it's really cool. You can have your private LTE network, go off net with devices, and still be connected back, go off net like on AT&T, and still be connected back to your private LTE network. So it's a pretty cool thing to do. Okay, so what are the differences between LTE and 5G? This is probably getting old at this point because everybody kind of knows, but the main difference is that's advertised as speeds and latency. And the speeds for 5G are like 10 times faster than the LTE speeds. But part of the reason for that is that 5G also can operate at millimeter wave frequencies. And the faster the frequency, the more data throughput you can have through that network. Not all of us that have private LTE networks can afford the spectrum that uses millimeter wave. So we're not going to get the speeds that faster frequency allows. And when you have a faster frequency, it's just RF theory. It's harder for shorter wavelengths to go through the earth and through buildings and through trees, so it goes shorter distances. So a lot of times, let's say if T-Mobile's using 5G and they're using that millimeter wave, then which is an expensive spectrum, it goes a lot shorter distances. So they might use picocells in a downtown area, and that 5G signal might really only go like 2 blocks or so. For us that are using private LTE and using 5G, we'll put it down on the spectrum that I'll talk about that we can use for private LTE, which is in the lower bandwidths like CBRS, which is 3 gig, or maybe band 41, which is 2.5 gig. But because it's a slower frequency, you don't get as much data throughput. So even if 5G has faster speeds, but maybe it might not have faster speeds if you use lower frequencies. That's just RF theory. The other thing that gives it more speed is the bandwidth. And typically, 4G radios have cell channels that are in increments of 20 megahertz. And you can aggregate those 20 megahertz together, but they're smaller 20 megahertz. 5G has their channel bandwidth for a channel is 100 megahertz. So it has a lot broader bandwidth to supply more data throughput and faster speeds. So the other thing that's affecting speeds is just the bandwidth chunk that 5G uses over 4G. Latency is again faster on 5G, but again that's because the speeds are faster, and if speeds are faster, your latency is lower. But it's also how far do you go? So you might be going faster, but if you're going out into a public 5G network where it has to get to a carrier's core and then back to your own private network, there's a whole bunch of latency. In a private LTE network, you would build your core on your site, on your premise, and have the data actually come out through there. So it's not going out into the cloud and coming back. It's still on-prem, and that really reduces the latency. So 4G and 5G could be comparable when you get down into the private LTE spectrums. The other difference, and this is starting to kind of null itself, but it used to be that just because that 5G was new, the availability of the equipment, it wasn't as available as 4G equipment, and the pricing was a little bit higher. It's still a little bit higher compared to 4G pricing. So that's like another consideration when you're looking at 4G versus 5G equipment. Some of the key features of private LTE is that it's standards based, and that's good just because it's because it's standards based. It's built on the 3GPP cellular standard. It makes it intercompatible. The radios are intercompatible, so you can use different radios. The evolved packet cores, or the cores that the radios are attached to, they're interoperable with other radios, and there's a whole bunch of different CPE equipment that's compatible with the 3GPP architecture. It uses dedicated spectrum. I'll talk about spectrum later, but dedicated meaning it's not using Wi-Fi where there might be everybody using it and there might be congestion and interference on the Wi-Fi spectrum. It has enhanced security, meaning it's SIM card based. SIM cards have their own inherent security scheme to them, and also just because it's built on 3GPP and the cellular standards, every air link and every link through a cellular core, that data is always in a tunnel. Even through the air links, it's in a tunnel, so it's secure. When Paris Hilton's cell phone gets hacked into, it's probably not the cellular network that they're going through to get into her cell phone. It's probably going through Wi-Fi on the cell phone or Bluetooth on the cell phone. Scalability, you can make it as big as you want or as small as you want. It's your own private network, so you can do what you want with it. It's customizable. You can build it for specific applications. And then this other important thing is that you can have edge compute on it, meaning you can have that core, or the interface from the core can actually integrate into your own LAN network, rather than getting a public service from T-Mobile and it goes out through their own network. So those are some of the features of it. The benefits of it is that it's reliable. It's not depending on Wi-Fi that might have congestion and interference. It's low latency, meaning it's your own private network. It's on your own prem. It's integrated to your own LAN. It's all local, so that the data is staying right in low latency within your application or on your premise, and it's not going out to a public service provider or going out into the cloud and coming back to you, making it lower latency. We talked about security, enhanced security, and that's just the way cellular was architected and developed to be secure. Flexible, I already talked about that. You can kind of build it for your own applications and your IoT devices, and make it edge compute and integrate it into your LAN network, making it cost effective. The other important thing is that it supports mobility, and we all know that using our cell phones. So here's some differences between private LTE and fixed point-to-point service, that like a fixed wireless service. So an example of a fixed point to multi-point network would be something like from Tirana or from Cambium. So I'm just going to go over some of these fast. Again, LTE is standards based. A point-to-point is proprietary. There's good and bad to that. A proprietary network, you can architect it or design it to do better things, that you don't have to stay open with an open standard. But then on the other hand, with a proprietary network, you have both like your CPE equipment, your end user equipment has to be purchased by the same company that you're buying your radios from. Devices can be fixed or mobile in a point to multi-point. Most of the time, the end devices are fixed for fixed wireless. The private LTE devices will require SIM cards. In a point to multi-point system, the devices don't necessarily use SIM cards, but those SIM cards provide security and they also provide a way to manage your user base or your subscribers, which becomes important. With Private LTE, you need what they call an evolved packet core. I'm going to talk more about that. You don't need that in a point-to-multipoint system. However, you still need, so the evolved packet core kind of manages everything in the cellular network or your Private LTE network. You still need some system, some portal, some cloud-based or portal-based management system to manage a point-to-multipoint system. So you still need some type of core for either of these networks. Transmits further, people will debate that. Some of the point-to-multipoint systems require line of sight. They might have less encoding schemes. That was more true in the past. Companies like Tarana that have point-to-multipoint, they don't need line of sight, and they do a great job. With a point-to-multipoint, you can design and control your end-to-end design because the endpoints are fixed. With a Private LTE network, the endpoints aren't fixed, so your design has to be a little bit more conservative because your devices may move around a bit. What else here? So the next one is beamforming. A lot of like Tarana does a great job with beamforming and multi-user MIMO, so they get multiple paths on their radios. In the past, that wasn't necessarily the case with Private LTE radios, but nowadays they are using beamforming and multi-user MIMOs to have multiple paths going out to subscribers. And then the last two, these are always debatable. It's the number of subscribers you can get per carrier or per sector. You might be able to get more on a point-to-point multi-system, but it's also based on the last point here, that typically a Private LTE radio has channels that are 20 megahertz, so they're smaller channels, so it can handle less subscribers and less bandwidth. Tarana, for example, can use a 40 megahertz channel. They can carry aggregate those to 240s to make 80 megahertz, so they can even double that to 160 megahertz channels, which gives more throughput and faster speeds. Oops, sorry. But it all kind of depends on how much bandwidth you dedicate to it. But I would say on the most part, LTE perhaps will have slower speeds than a dedicated point-to-multipoint system. And then here's the differences between Wi-Fi and Private LTE. It's kind of a perception. LTE might be perceived as being a little bit more difficult to deploy because you have SIM cards and a core that you need to manage. Wi-Fi might be easier. I think Wi-Fi might be easier because it's been around longer. And people are used to it. Even with Wi-Fi, just like that core that you might need for Private LTE, Wi-Fi still kind of needs a core or a management system to manage all your APs or your access points all together, to manage your subscribers. So you're still dealing with some kind of management system. So this evolved packet core that LTE has, it might be perceived as being more difficult because it's a mystery and people don't know a lot about it, but it's really no different than some other management system that you might have for Wi-Fi. The Wi-Fi it runs at unlicensed spectrum at 2.45 and 6 gig. The benefit of LTE is that it uses more dedicated spectrum. I'll talk about spectrum in a little bit here, but CBRS is you get dedicated channels to use in your Private LTE network. And then there's another spectrum called band 41 or EBS, and that also gives you dedicated spectrum. So you're not dealing with interference and congestion that you might deal with on a Wi-Fi network. Transmits further. I worked at Ruckus. We sold and developed both Wi-Fi access points and LTE access points, and we always said that an LTE access point covers 4 times the area on average than 4 Wi-Fi access points. So it has better coverage, and that's more just because of higher output and the encoding schemes that cellular uses. Private LTE has no comparison on speeds compared to Wi-Fi. I'm not going to talk too much more about that. The other important thing is LTE radios. LTE, you can mesh Wi-Fi access points together. So you can kind of go from Wi-Fi access point to Wi-Fi access points to Wi-Fi access points and then back to a network. You can't mesh, right now you cannot mesh private LTE radios. So you're going to need more backhaul for private LTE. Private LTE cellular was designed for mobility. The first architecture was cell phones in your car, right? That was the first application for cellular. So the original architecture for cellular was to be mobile and to hand off between cell sites. Wi-Fi was designed to remove cables from your cubicle. So it wasn't necessarily designed from the start to be mobile and to hand off from access point to access point, because it was meant really just to replace the cables at your desk. There are roaming or handoff capabilities that Wi-Fi is working on, but private LTE is still more robust in that arena. I talked about beamforming. Wi-Fi does a lot of beamforming, but private LTE's radios are starting to do that too. And then the other important thing is the thing that I talked about. You can roam off net and go from indoors to outdoors on a private LTE network and go across the country if you roam onto another carrier and still be on your private network. Where Wi-Fi, you really can't do that unless you do stuff with Hotspot 2.0 and stuff. Use cases, I'm going to try to speed up here. So I won't talk about use cases. I think you can kind of find all over the place, but for the most part, you would use a private LTE network when perhaps your Wi-Fi is not efficient enough because of interference and congestion or coverage or reliability, or where you might have a critical application that you don't want to put on a Wi-Fi network and that you want to put it on a dedicated network. Again, it's also this when mobility, I mean like going between cell sites or access points is more important for your application. Then private LTE works better in that manner over Wi-Fi. I'm not saying that private LTE is a replacement for Wi-Fi. Wi-Fi has been around forever. It's going to be around forever. Private LTE is not meant to be a replacement, but it can be an enhancement where your Wi-Fi network might not be good enough for critical applications, and you want to put those critical applications on a network that has dedicated wireless channels to get dedicated throughput for that critical application. The number one in the past, the number one use case for private LTE has been fixed wireless access. That's been probably the most popular since CBRS came out. There's lots of use cases for mining and manufacturing, warehousing and ports and agriculture where you want to control equipment that's moving around between access points or between radios for remote control and inspection. I went to an airport and on a sales call, and they kind of said, "Why are you here? Trying to sell us private LTE? We have we have Verizon's on in our airport, and Boingo's doing our Wi-Fi. So we really don't have a need for private LTE. And my question to him was, where's your Wi-Fi not working good enough for an application? And you're asking that to the Wi-Fi networking guy, and his Wi-Fi network works perfectly, right? But there was, after a little bit of silence, there was somebody that said, well, we do have a tram, a railroad tram that goes 1.5 miles up and down a north terminal that has security cameras on it. And because it's 1.5 miles long, they tried to use Wi-Fi for those security cameras, and it didn't work because it wasn't handing off between these Wi-Fi access points fast enough. This is a perfect use case for private LTE because it's meant to hand off between radios. So this was, and their Port Authority Police Department was getting mad at them because they didn't have the security cameras on it, which became a liability to them on these trains. So private LTE was a perfect use case where it's a critical application, and it served it better than a Wi-Fi network did. Again, just an overlay to the Wi-Fi network. You can use it in municipalities. The other thing that's happening is they might a municipality will have it in their vehicles for data, for communications. That's private. Again, because it's private, you can bring it back to your own data network and your own servers. Another popular one is backhauling Wi-Fi in public parks on a private LTE network outdoors. Security cameras has been like the #1 demo use case for private LTE. Think about like a school district where they're using security cameras that are wireless, and if an event does happen at that school, both the Wi-Fi network and the public cellular network get crowded, and you don't want to rely on Wi-Fi in a crowded network for a security camera, so you put it on a dedicated private LTE network. Tribal nations, I'll talk about Band 41, but tribal nations have Band 41 licenses. It's under a use it or lose it kind of license, and it's a perfect way to use that license and also use it for fixed wireless access in their communities. We have at Winncom, we have customers that use radios at sporting events to support cameras for the broadcasting of it, and also for point of sale. So when you get event sites that are crowded, there are a lot of people using Wi-Fi and using cellular, putting your point of sale to make sure you make revenue during that event on a private LTE network makes total sense. And then medical, there's a lot of patient monitoring going on with Wi-Fi, different diagnosis machines, but at the same time, patients are using Wi-Fi to stream Netflix and all their video. So you don't want to put a critical patient application on a wireless network that's being used to stream video. You want to put it on a dedicated network. Here's the architecture, a brief overview of the architecture for a private LTE network. It consists of CPE or user equipment. All that user equipment to make it private LTE will need to have SIM cards in it. You need spectrum for private LTE. Right now it's the easy ones are band 48, which is CBRS, or band 41, which is the educational broadcast spectrum. I'll talk more about that. And then you need radios. You need a whole bunch of different things that go with the radios. And then you need an evolved packet core that then connects out to either the internet, the public internet, or you can have that data stream actually go into your enterprise LAN network and just remain private on your own network. I'm going to go over each of these. So radio network, There's all sorts of different kinds of radios and manufacturers' radios. There's indoor radios, there's outdoor radios, and there's radios that may be perceived as being simpler or maybe a little bit more complex but more robust. Bicells makes great radios. They make indoor and outdoor. They make 4G, 5G radios. They're standalone small cell radios or macro radios, but they're kind of they have a baseband that's integrated into them, so they're kind of standalone. They have a cloud core EPC that just makes it super simple to deploy, to quickly deploy and manage. Super simple. You can go up the spectrum to more of the radios that the tier ones use, like from Nokia or Ericsson. They get a little bit more complicated because you have a baseband that goes along with them, that goes up to radios. You also need antennas, and some of the, like even Bicell, some of the antennas are integrated, but some of their radios need separate antennas that go along with them. And then both Ericsson and Nokia make bundled packages of radios and cores and make everything bundled together. So Ericsson has this thing that they call the EP5G, which is a bundled package. Nokia has their NDAC, which is exactly the same thing. What's shown on the bottom there is Ericsson's indoor radio solution. And this is kind of neat because it's you deploy it indoors, but you can, like I talked about before, you can also use this as a digital DAS. So you can feed this with band 48 and have your own private LTE network, but you can also integrate like a tier one's signal into the baseband and then broadcast out the tier one's signal inside the building, just like a DAS system, but it's a digital DAS system. I worked at a company where we did this for a tribal resort in the Pacific Northwest, where they didn't have any coverage at all, because typically they're kind of out in Washington, they're out in the woods or out in the mountains, and away from the population. So they didn't have T-Mobile or they didn't have cellular coverage at all. So we used these radio dots and brought in AT&T signal and Verizon signal. And then we also deployed, on top of this, on the same network, we deployed a private LTE network that they use for communications for their hospitality and for their staff. Here's the other component of the architecture for private LTE is what they call an evolved packet core. It kind of makes it all run and makes it work. It's all still, again, built on 3GPP standards. There's a quick drawing of it. It's, again, because it's built on standards, it's got lots of acronyms and signaling interfaces and super complex. The thing is, you don't, to deploy a network, private LTE network, this might be complex, but you don't need to necessarily know it all. It can be the wizard that's behind the curtains, and all these little subsystems and things that make it work can remain a little bit hidden, or you can get into them if you want, but it doesn't need to be a mystery. Winncom can help you with all sorts of different solutions for evolved packet cores. Like I said, you can use it with different radios. Bicell has their simple cloud core, which is cloud-based, makes it really easy to get a network up and running. Druid sells EPC software as a capital expense, so they sell their software on a perpetual right to use, and it's billed by how many users you might have going through that evolved packet core. Another company, Penta, it's more on it's a EPC as a service or a cloud-based service. It has an edge component to it, so you can keep it local. But their business model is under a subscription, so it's more of an OpEx expense. All these have OpEx expenses because there's always like a yearly maintenance fee to them. Nokia has their own CMU Evolve Packet Core. Ericsson, like I talked about, has this bundled EP5G core. So Winncom can help you guys with what EPC to use. We can give you demos of these EPCs if you want to look at them. Some of them are maybe a little bit more robust on their web GUIs, easier to kind of manage and look at. But we can help you decide which ones you are right for your application, and we can demo them if you want to contact us. So Spectrum, I'm going to go super fast on this because I'm kind of running out of time. For us that use private LTE that don't want to spend a lot of money, there's kind of two spectrums. There's the number one spectrum is CBRS, which is band 48. CBRS is a managed spectrum, and that's why you can have these dedicated channels instead of the interference that you get with Wi-Fi. But it has it's managed through what they call a SAS, or a spectrum allocation system, which is provided by like maybe Google or Federated. That and the band 48 CBRS radios have to communicate to the SAS system in order for the FCC to assign it a frequency to use into broadcast. And that's all done automatically behind the scenes, but you need an internet connection between your radio and the SAS to get the radio a channel to broadcast on. And then band 41 was a band that the FCC had for educational broadcast service a while back. It was meant for remote teaching, remote learning. A lot of schools didn't really pick up on it too much. Then it was offered to tribal nations. Tribal nations picked it up, but didn't use a lot of it. And then they, the last 4 or 5 years ago, they actually put it up for auction, and the rest of it was auctioned out. A lot of tribal nations still have band 41, and they're using private LTE to build out networks throughout their tribal nation. That's another big use case. And then the CPE equipment, like I said, all these need SIM cards. Because it's based on standards, you can, and that's the nice thing compared to maybe a proprietary point-to-multipoint system. There's different CPE devices for every different application. There's point-of-sale devices, there's routers, there's phones. The best thing if you're building out a private LTE network is to get an Android phone, because the Android phones have a lot of applications that you can use to actually kind of analyze and monitor and look at your private LTE network. Lots of applications for that. Tons of stuff. The important thing is you want to make sure that your CPE supports the bandwidth that you're using. So it supports CBRS band 48 or band 41 or whatever spectrum you're using. If you buy spectrum from another carrier, you want to make sure that CPE supports it. And you want to make sure that if you're trying to build out a 5G network or a 4G network, some equipment is only 4G capable, some of it's 5G. Typically if it's 5G capable, then it's also 4G capable. But you gotta watch what you're getting. And there's also what they call ODUs, or outdoor units. Those are meant for fixed wireless access to be mounted. So you can use private LTE for fixed wireless access. Winncom will help you with any of the CPE and help you find it and help you with the right CPE for your applications. The other important thing is to do some type of design for your network, whether it's indoor or outdoor. This is an example of Google Network Planner, which is going away apparently. But Google Network Planner was easy to use. There's a whole bunch of them. Federated Wireless is coming out with one. InfoVista has one. Cyrodiil has one. HDZ, Atoll. IBWave is probably a really, really good one for indoor Wi-Fi, but also indoor private LTE. you kind of need to do it. The big question is, how far does it go? And you're not going to know how far RF goes without looking at terrain and obstacles and trees and whatnot. So you need to do a predictive coverage on your network. So as far as deployment, I don't know. You typically see private, or when you drive around, you see radios on the towers. You can build an outdoor private LTE network, but it doesn't necessarily have to be on the tower. You can build them on rooftops. You can put them in light poles. You can put radios on light poles. We have lots of customers putting them on water towers. You can put them inside your warehouses. You can put them inside your offices. So there's all sorts of deployment scenarios. This is an indoor deployment scenario. Again, built out pretty much just like Wi-Fi. You would want to have like a local EPC on a server, or like a HyperEdge device that would the data plane comes out of the EPC, and then that way you can integrate it straight into your LAN network if that's what you want to do. Making it totally private. Your data can stay right on your own prem. You can firewall it. You can you can keep it there, and then obviously you can get internet access on it. The other, I'm saying that the data plane comes out of the EPC. Bicells does a really cool thing where they have a local gateway breakout from their radio, so you can have the radio integrated into your LAN network and still use their cloud core, which is obviously out in the cloud. But the local data plane still, or the data plane from the radio stays local. A lot of radios don't do that. And then here's a typical deployment. You're going to need, and I'll go into more detail on this, but you have your radios, your tower, your antenna, your GPS. Private LTE radios a lot of them need a GPS signal to them just to synchronize them. That would come down to a cabinet or a box that goes through some type of networking switch. All these radios need to be tied back to a network, whether that's over fiber or an IPsec tunnel over the internet or a microwave link. But then it comes back to your evolved packet core, where we may have that. It could be in the cloud, it could be on your prem, and then you'll have a radio network management system to go to it, and then out to your internet or into your LAN network. These are the details. So most radios, some of them have internal antennas, but most of them will have external antennas. You need RF jumpers that'll go to the external antennas. The radios typically they need DC power, so you need a DC power supply that goes with it from your network or from your baseband. If you're using like Ericsson or Nokia, you have fiber optics that'll go up to each radio from your baseband. If you're using something like Bicells, you still need it to attach back to a router that then would go out to either the internet or back to your data center or back to your headquarters. These are all the components that you need. Typically, you would, at the base of the tower, you would put these in a cabinet. This could also be on a rooftop, where this is just a room on the rooftop, but you still have all these components. Let me see if I have any notes there. And then so Winncom at Winncom we sell all these components, all the RF cabling, the DC power plants, the routers, the antennas, the radios, the cabinets, even the towers. We sell all that. We can be your one-stop shop to provide all that for you and help you engineer through it. The other thing that we recommend, rather than having all these individual, let me go back a slide. Rather than having all these individual cables going up the length of your tower, or going from the top floor of a building up to your rooftop, instead of having all these individual power cables and optical cables that need to go to each radio, we recommend using a hybrid cable that basically has all those cables inside of it, and then using a breakout box at the top of your tower on your rooftop, but also down where your equipment breaks out. And then from that breakout box, you bring out the shorter power cables and optics that would go to each radio head. So at Winncom, we can provide all the things that I talked about. We can help you with all the deciding on RAN infrastructure, the radio infrastructure. We can help you with all sorts of CPU equipment. We can help you with all the Evolve packet cores that I talked about and help you decide on which business model is better for you. We have all the antennas and the power supplies and the tower and the site material, everything that goes with it for building out your network. And then we have the professional engineering and design services that go with it, and we'll help you with the pre-configuration, the configuration, the integration, project management, and any support that you guys need. And I think that's it. And I don't know how much time I have. Yeah, thank you guys for attending. If you have any questions, we're going to open it up for questions, but if we run out, take down my name. There's a Winncom web page, but ask me questions if you have questions. Don, are there questions that came across?
I think you did such a great job explaining to everyone. You only have one question out here, and it is band 48 or 41 available for private utilities, and are these bands owned by spectrum managers?
So band 48 is available to everybody. Like I said, it's managed by, so the FCC made CBRS available maybe 4 or 5 years ago now, maybe 4 years ago. It's a band of spectrum, 150 megahertz of spectrum. It goes from 3.55 gigahertz to 3.7 gigahertz. It's available to everybody. They don't charge for it, but it's managed. So it's managed by these spectrum allocation systems, which it can be done either through like Federated Wireless or Google. So it's free spectrum, but you need to pay to have it managed by one of those guys. And it's actually really cheap to have it managed. So it's a very inexpensive spectrum that's available for private LTE to everybody in the United States. And it's relatively inexpensive. Band 41, if you don't have a band 41 license, a lot of tribal nations, like I said, have band 41 licenses. When they did the auction, I think T-Mobile bought up a lot of band 41. But there are brokerage firms that you can go through and maybe sublease band 41. But then your band 41, you're gonna pay for it more than probably you would for CBRS. But CBRS is available for everybody. And then there's other spectrums and there's other brokerage companies where, if a carrier owns spectrum and they're not using it, they'll more than likely lease it to you. It's just you gotta find that brokerage company, and then there's a cost to it. There's more of a cost than band 48 or CBRS.
Well, speaking of other spectrums, another question just popped up. Is there a reserved municipality spectrum, like similar to the wireless internet services, Ethernet services?
So, originally, like band 41, the original intent for band 41 was educational. But a lot of schools just didn't use it for distance learning. And then I think they opened it up for municipalities. So I think a lot of municipalities did get band 41 licenses. But not a lot of them used it. It's under a use it or lose it. And then it opened up for tribal. So band 41 was kind of meant for municipalities at one point. And CBRS is obviously can be used by anybody, but a lot of municipalities that I've worked with are using band 48 or CBRS. But there's not necessarily one that's other than those two that are set up just for municipalities that you would use on a private LTE network. You might be able to use them on some type of like LAN mobile LAN service, but not on private LTE.
Okay, great. We have more questions coming if you have time.
Sure.
Do you offer vendor support or additional services to help set up a network with voice capabilities?
Yeah, we don't do that right now. I'm happy to help anybody with consulting on their voice services, but it's more it's getting that IMS component in your Evolve packet core, um, which I believe a lot of them do provide that IMS subsystem, but then it's integrated into either your local PBX, which we don't, Winncom doesn't necessarily sell PBXs, or do that kind of voice over IP or voice over LTE integration. And then if you wanted it to be a public cell phone where you can use native dialing, then you would need to get like a SIP service from some, SIP service provider like Alianza or anybody that provides voice over IP as a service. We can help you with that, but we don't necessarily have, other than the IMS that's in the Evolve packet core, we don't necessarily have those other elements. But we'll help you. We'll help you go through it.
Okay, great. Can you easily mix band 48 and private 900 megahertz from a brokerage company?
They're used for different things. So on a private LTE network, you're going to use these small cell or macro or pico radios, and that's another important thing about the radios and choosing the right radio. Most of those radios are dedicated to a certain spectrum, right? So either at Bicells or Nokia or whoever, a lot of the radios are uniband, which means they'll just support, it's a radio model for band 41, a different radio model for band 48. So you have to watch what you're getting. You wouldn't on these radios, they use like the bands, but you're not going to use like a 900 megahertz on a private LTE radio. They don't support that. You can overlay the networks on top of each other, but you wouldn't, like a private LTE radio that you get from Bicells or Nokia or Ericsson or whoever, any of the other ones, they don't necessarily support 900 megahertz on their radios.
Okay, great. I apologize. We have one more question for you. Is the use of SAS required when you are deploying outdoor CBRS radios only?
Yes, SAS is always required. No band 48 radio, whether it's indoor or outdoor, will broadcast unless it goes through SAS. SAS gives it the grant gives your radio the grant to broadcast, and it's all done machine to machine, so it's not like you configuring it. But yes, for any CBRS spectrum that gets assigned to a radio, it has to go through SAS. You can illegally do it. You can even like with Bicells, you can turn SAS off, but then you're being illegal.
That is all the questions that we have for today. If I could just thank you to you, Michael, and as a quick reminder to our listeners that we will be sending out an email shortly with all this information. So just please keep an eye out for that.
Thanks for attending, everybody.